Okay, so ladies and gentlemen, we are all welcome to my YouTube channel. Today we are going to look at how to calculate possible number of isomers of alkane. And remember, the first member of alkane is ethane, is methane, CH4. This is methane. That is the first member of alkane. We have methane, and then we have C2H6, which is ethane. Ethane. Then we have C3H8. This is propane. This is propane. So these are the first three members of alkane. And strictly speaking, these three members do not have isomer. So they do not have any isomer. No isomers. They doesn't have isomers. So they doesn't have isomers. They doesn't have. So these three members of alkanes, they doesn't have any isomers. They doesn't have any isomers because this is the only structures they only have this. They only have one structure. It doesn't have any other form of structure. And remember when we said isomers, it means that a compound that doesn't have, a compound that have the same molecular formula but different structures. So from methane, ethane, and propane, they all have one structure. So that is why, because they have only one structure, that is why they do not exhibit isomerism. And the next member of alkane is butane, and butane have 4 carbon. It has 4 carbon. So the first carbon is having 3 hydrogen, and the second carbon has 2 hydrogen, and then the third one also has 2 hydrogen, and then the last one has 3 hydrogen. So you can clearly see that here we have 4 carbon. So we have 4 carbon atoms here. So this one is called normal butane, N-butane. It's called normal butane. But at the same time, this butane or this C4, because the general formula of this compound, or the molecular formula of this butane is C4, is C4H10. It's C4H10. So, and this is the normal butane. This is the structure of the normal butane. But at the same time, this butane can also exhibit another structure. So we can have something like this, CH3, and CH here, and we have CH3. Then here, another CH3 will be attached. So if you can see clearly, this structure and this structure are not the same. There is a branch at carbon 2 in the second compound, but this one is normal. It's linear. But if you look at them, you can clearly see that this one have 4 carbon and 10 hydrogen, and it has this C4H10, and this one is also having 4 carbon, 10 hydrogen. So it means that the structure, if you look at this structure, is different from this one, but their molecular formula is the same. They all have C4H10, but in terms of structure, they are different. So this is what you call isomerism, to have a compound with the same molecular formula but different structure. So this phenomenon is called isomerism. So it means that clearly here we can see that butane has 2 isomers. It has 2 isomers. The first one is the first structure, and the second one is the second structure here with a branch. And of course, even in terms of their name, they are differ. Even in terms of name, they are differ. Like the second one here is 2-methyl, is 2-methyl, because at carbon 2 here there is a methyl, so it's called 2-methyl propane. So this is what you call isomerism. So we can actually calculate the possible number of isomers of alkane. We can clearly do that. Like for example, the formula that is generally used in calculating the isomers of alkane is this. So now, for example, if you want to calculate the number of possible isomers, you can use a formula. The formula is 2n, 2 raised to the power of n minus 4 plus 1. 2 raised to the power 2 raised to the power of n minus 4. This is the formula that we use in calculating the possible number of isomers of alkane. Like for example, let's start with methane. Methane has C4, CH4. This N it means the number of carbon. The N here means the number of carbon. The number of carbon. It means the number of carbon. It means the number of carbon. So like in the case of methane, the number of carbon is 1. So the number of carbon is 1. So we can now say 2, because N is 1. So we have 2 raised to the power of 1 minus 4 plus 1. So 1 minus 4, we have minus 3. So 2 raised to the power of minus 3 plus 1. So because this one is negative, so we are going to neglect it. Since it is negative, we are neglecting it. So we are going to neglect it. Neglect. So we are neglecting it. So since we are neglecting this, then it means that this one will be considered as 0. So for CH4, we have 1. So it means that the number of isomers for methane is 1. It means that it has only one structure. It means that it has only one structure. Then the next one. So therefore now in the case of ethane, where we have C2H6, C2H6, so we are going to take the same formula, 2 raised to the power of n minus 4 plus 1. So the number of carbon here is 2. So it means we have 2 raised to the power of 2 minus 4 plus 1, which is equal to 2 raised to the power of minus 2, 2 raised to the power of minus 2 plus 1. And this one is negative. We also neglect it at the same time. So it means that the number of isomers of ethane is 1. So it can only form it has only one structure. So that is why we said it doesn't have isomers. Then another example is in the case of propane. So the propane also have a formula. Propane also has a formula of C3H8. C3H8 has a formula of C3H8. So we are going to apply the formula 2 raised to the power of n minus 4 plus 1, which is the same thing as 2 raised to the power of 3 minus 4 plus 1. And at the end, we have 2 raised to the power of minus 1 plus 1. And this one is negative. We also neglect it. So we have 1. So that is why methane, ethane, and propane, they only have one isomer. So that is why we said they do not exhibit any isomerism. So now the next thing, let's take butane. Butane has a formula of CN, has a structure of the formula for butane is C4H, C4H10. So if we now take the formula 2 raised to the power of the n reflects the number of carbons we have, 4 minus 4, then plus 1 is equal to 2. So 4 minus 4 is 0, then plus 1. So any number raised to the power of 0 is 1. So we have 2 raised to the power of 0 is 1. And of course we have 1, so plus 1. Then we have 2. So that is why butane here, it means that butane has 2 possible isomers. Butane has 2 possible isomers, while methane, ethane, and propane, they only have 1 isomers. Then another example is let's take example of propane. Propane have a formula, have a general molecular formula of C5H12, C5H12. And of course, by taking the formula, we have 2 raised to the power of n minus 4 plus 1. So it means that we have 2 raised to the power of 5 minus 1. 2 raised to the power of 5 minus 4 plus 1. So therefore, 5 minus 4, we have 2 raised to the power of 1 plus 2. And any number raised to the power of 1, it is that number. So 2 power 1 is 2, so 2 plus 1 is 1. So we have 3. We have 3. So we have 2 raised to the power of 1 is 2, then plus 1, we have 3. So it means that pentane have 3 isomers. Then the next one is hexane. Hexane, C6H14. So we use the formula 2 raised to the power of 6 minus 4 plus 1. So we have 2 raised to the power of 2 plus 1. So 2 raised to the power of 2 is 4 plus 1. It means that there are 5 possible isomers for hexane. And then the next one is heptane, C7H16. So we now say 2 raised to the power of 7 minus 4 plus 1, which is equal to 2 raised to the power of 3 plus 1. And of course, 2 raised to the power of 3, it means 2 times 2 times 2, which is 8 and plus 1. So it means that heptane have 9 possible isomers. It has 9 possible isomers. Then the next one is octane. Octane. So this formula, 2 raised to the power of n minus 4, it only applied to methane to heptane. It doesn't apply to octane, and it also doesn't apply to nonane. So for the octane, which formula are we going to use? So for octane, we are using for octane, we are using a formula 2 raised to the power of n minus 4 plus 2. So in this case, we are using plus 2 instead of so for octane with 8 number of carbon, for octane with 8 number of carbon, so we are using this formula. So for octane with 8, we have 2 raised to the power of 8 minus 4 plus 2. So therefore we have 2 raised to the power of 4 plus 2. So 2 raised to the power of 4 is 2 times 2 times 2. That is something like this. 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So 16 plus 2, we have 18. We have 18. It means that octane has 18 possible isomers. Then the next one is octane. Also, this formula is not applied to nonane. So for nonane, we use 2 raised to the power of, for nonane, we use 2 raised to the power of n, 2 raised to the power of n plus, 2 raised to the power of n minus, we use 2 raised to the power of n minus 4 plus 3. So this is for nonane. This is for nonane. That is the one with 9 carbon atoms. So nonane has 9 carbon atoms. So we have 2 raised to the power of 9 minus 4 is 2 raised to the power of 5. So we have 2 raised to the power of 5 plus 3. So 2 raised to the power of 5 is equal to, or is going to be 32. And then 32 plus 3 is going to be, yes, 32 plus 3 is going to be 35. So it means that nonane nonane has a possible isomers of 35. Nonane has a possible isomers of 35. So ladies and gentlemen, thank you for listening. And please, at the end of this video, I wish you can subscribe for more video content. Thank you.